ಎಲ್ಲ ನನ್ನ ಪ್ರೀತಿಯ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ನಮಸ್ಕಾರ. Today I will be discussing on Unit 2 of Hydrology, Runoff process. This comes under the subject Water Resource Engineering. I am Dr. H. Chandrasekhar, Selection Grade Lecturer, Department of Civil Engineering, presenting this topic today. In today's session, following are the topics covered. First is runoff process. Second, estimation of runoff. Third, factors affecting runoff. These three aspects we will be covering in today's class. In previous session, we had studied hydrograph and abstraction from precipitation. This we have studied in our previous class. We will have a recap of what we studied in our previous class, and then we will discuss about today's class. What is the recap of our previous class? We have discussed on hydrograph. What is hydrograph? It is a graphical representation of discharge along y-axis and time along x-axis. This plot of discharge versus time, we call it as hydrograph. If you draw the hydrograph, this hydrograph represents the discharge at different intervals of time and the area below the hydrograph. This is an hydrograph. This is the curve. You can see how the curve is formed. This is called a rising limb. This is falling limb. The area enclosed between this hydrograph, that gives you volume of discharge which has been flown through that particular stream. These hydrographs are plotted across streams, right? A stream across ಅಲ್ಲಿ ನಾವು ಇದನ್ನು ಯಾವುದೇ ಒಂದು ಸ್ಟ್ರೀಮ್ ಇರುತ್ತಲ್ಲ, ಒಂದು ವಾಟರ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರುತ್ತೆ. ಆ ನದಿ ಆಗ್ಬೋದು ಅಥವಾ ಚಿಕ್ಕ ತೊರೆ ಆಗ್ಬೋದು ಅಥವಾ ಸ್ಟ್ರೀಮ್ಸ್ ಆಗ್ಬೋದು. ಇಲ್ಲಿ ಎಷ್ಟು ನೀರು ಹರಿತಾ ಇದೆ, ಎಷ್ಟೆಷ್ಟು ಗಂಟೆಗಳಲ್ಲಿ, ಎಷ್ಟೆಷ್ಟು ಟೈಮಲ್ಲಿ ಎಷ್ಟೆಷ್ಟು ನೀರು ಆ ನದಿ ಮೂಲಕ ಹರಿದಿದೆ, ಇದನ್ನು ನಾವು ಪ್ಲಾಟ್ ಮಾಡ್ತೀವಿ, ಗ್ರಾಫ್ ಮೂಲಕ ಪ್ಲಾಟ್ ಮಾಡ್ತೀವಿ. ಒಂದು ರನ್ಆಫ್ನ, ಒಂದು ಡಿಸ್ಚಾರ್ಜ್ ಅಥವಾ ರನ್ಆಫ್ನ ವೈ ಆಕ್ಸಿಸ್ ಮೇಲೆ, ಟೈಮ್ನ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಮೇಲೆ ಪ್ಲಾಟ್ ಮಾಡ್ತೀವಿ. ಆ ಟೈಮು ದಿನ ಆದರೂ ಆಗ್ಬೋದು, ಗಂಟೆಗಳಾದರೂ ಆಗ್ಬೋದು. ಎವ್ರಿ ಒಂದೊಂದು ಗಂಟೆಲಿ ಎಷ್ಟೆಷ್ಟು ನೀರು ಫ್ಲೋ ಆಗಿದೆ ಅಂತ ನಾವು ನೋಡ್ಬೋದು. ಮಳೆ ಜಾಸ್ತಿ ಬಂದಾಗ ಏನಾಗುತ್ತೆ, ಮಳೆ ಬಂದಾಗ ನದಿನಲ್ಲಿ ನೀರು ಜಾಸ್ತಿ ಫ್ಲೋ ಆಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಆ ನದಿನಲ್ಲಿ ನೀರು ಹೆಚ್ಚಾಗುತ್ತೆ. ಮಳೆ ಬಂದಷ್ಟು, ಮಳೆ ಬರ್ತಾ 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 ಏನಾಗುತ್ತೆ, ನೀರು ಹೆಚ್ಚಾಗುತ್ತೆ. ನೀರು ಹರಿಯೋದು ಹೆಚ್ಚಾಗುತ್ತೆ. ನೀರು ಹರಿಯೋದು ಹೆಚ್ಚಾದಷ್ಟು ಇಲ್ಲೇನಾಗುತ್ತೆ, ಈ ರೈಸ್ ಆಗ್ತದೆ, ಈ ಲಿಮ್ ವಿಲ್ ರೈಸ್ ಆ್ಯಂಡ್ ದಿಸ್ ವಿಲ್ ಬಿ ಪೀಕ್. ಇಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಡಿಸ್ಚಾರ್ಜ್ ಆಗಿರುತ್ತೆ. ಮಳೆ ನಿಂತ ಹಾಗೆ ಅದರದ್ದು ಸಹ ಆ ಡಿಸ್ಚಾರ್ಜು ಸಹ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಈಗ ಬರುತ್ತೆ. ದಿಸ್ ಇಸ್ ವಾಟ್ ದ ರೈಸ್, ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ದ ಪೀಕ್ ಡಿಸ್ಚಾರ್ಜ್, ಪೀಕ್ ಫ್ಲೋ, ರೈಟ್? This is rising limb, this is falling limb. This curve we call it as an hydrograph, right? ಇದನ್ನು ಹೈಡ್ರೋಗ್ರಾಫ್ ಅಂತ ಹೇಳೋದು. ಅಬ್ಸ್ಟ್ರಕ್ಷನ್ ಬಗ್ಗೆ ನಾವು ಓದ್ ಕ್ಲಾಸಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ. ಯಾವುದ್ಯಾವುದಪ್ಪ ಅಬ್ಸ್ಟ್ರಕ್ಷನ್ ಅಂದರೆ, ಇನ್ಫಿಲ್ಟ್ರೇಷನ್ನು, ಡಿಪ್ರೆಷನ್ ಸ್ಟೋರೇಜು, ಎವಾಪರೇಷನ್ನು, ಟ್ರಾನ್ಸ್ಪಿರೇಷನ್ನು, ಎವಾಪೋಟ್ರಾನ್ಸ್ಪಿರೇಷನ್ನು, ಇದೆಲ್ಲ ಲಾಸಸ್ಸು. ವಾಟರ್ ಲಾಸಸ್ ಅಂದ್ರೇನು? ಪ್ರಿಸಿಪಿಟೇಷನ್, ಎಷ್ಟು ಮಳೆ ಆಗುತ್ತೆ ಮತ್ತು ಎಷ್ಟು ನೀರು ಭೂಮಿ ಮೇಲೆ ಹರಿದೋಗುತ್ತೆ. ಇವೆರಡೂ ಡಿಫರೆನ್ಸ್ ಇದೆಯಲ್ಲ, ಇವೆರಡನ್ನು ಮೈನಸ್ ಮಾಡಿದ್ರೆ ಪ್ರಿಸಿಪಿಟೇಷನ್ ಮೈನಸ್ ಸರ್ಫೇಸ್ ರನ್ ಆಫ್, ದಟ್ ಗಿವ್ಸ್ ಯು ವಾಟರ್ ಲಾಸ್. ಎಷ್ಟು ನೀರು ಲಾಸ್ ಆಗಿದೆ ಅನ್ನೋದು ಸಿಗುತ್ತೆ. ಯಾವ್ಯಾವ ಮೂಲಕ ನಮಗೆ ನೀರು ಲಾಸ್ ಆಗುತ್ತೆ? ವಿಚ್ ಆರ್ ದ ವೇಸ್ ಬೈ ವಿಚ್ ದ ಲಾಸ್ ಆಫ್ ವಾಟರ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್? ಇಟ್ ಮೇ ಬಿ ಡ್ಯೂ ಟು ಎವಾಪರೇಷನ್, ಟ್ರಾನ್ಸ್ಪಿರೇಷನ್ ಫ್ರಮ್ ದ ಪ್ಲಾಂಟ್ ಸರ್ಫೇಸ್, evapotranspiration, the combined effect of evaporation and transpiration, we call it as evapotranspiration. Depression storage, the water gets stored in some depressions, we call it as depression storage. And there is a chances of infiltration also, the water gets infiltrated into the earth surface. These are the different types of losses. These different types of losses we have discussed in our previous session. Okay, let us have a recap of the various losses. One is the evaporation, as I mentioned you, because of the temperature, sunshine, there is a chances of water particles escaping from the water surface. the water gets evaporated, vapors will be formed, right? Because of these vapors which is formed, the water escapes into the atmosphere. It also depends on the vapor pressure at the surface water, temperature, wind velocity, atmospheric pressure, soluble salts from atmosphere, and heat storage in the water bodies. How much quantity of heat is stored in the water bodies. This evaporation depends on all these factors. Evaporation is a process by which the liquid changes into gaseous state. Whatever the liquid which is present in the water bodies, they gets converted into gaseous state in the form of vapors, in the form of water vapors. This process we call it as evaporation. This evaporation can be measured using an instrument called as evaporimeter. In India, we are following ISI standard evaporation pan. ISI standard evaporation pan is used to determine evaporation. Next is transpiration. Transpiration is the process by which water is lost from the plant body. Either it may be through the leaves or it may be through the stem. Whatever the water which is absorbed by the roots of the plants, the roots of the plants are going to absorb the water, and water is utilized by plants for their preparation of food. Remaining water which is unutilized or unused, this water which is unused escapes into the atmosphere in the form of water vapor. This we call it as transpiration. Next is evapotranspiration. Some part of the water from the trees and leaves escapes into the atmosphere, either also from grass, right? You can see here, from grass the water escapes into the atmosphere, from leaves of the trees the water escapes into the atmosphere. This is, we call it as transpiration. Then whatever the soil which is surrounding the plants, right, this soil also will be in wet condition. Water will be content will be present in the soil. Gradually the water content which is present in the soil also gets evaporated. ಅದು ಸಹ ಎವಾಪರೇಷನ್ ಆಗುತ್ತೆ. ಯಾವುದು? ಮಣ್ಣಲ್ಲಿರುವಂಥ ನೀರಿನ ಅಂಶ, ಮಣ್ಣಲ್ಲಿ ಏನಿರುತ್ತೆ ತೇವಾಂಶ, ಅದು ಸಹ ಈ ಮಣ್ಣಿನಿಂದ ಈಚೆ ವಾಟರ್ ವೇಪರ್ ಆಗಿ ಈಚೆ ಬರುತ್ತೆ. ಇದನ್ನು ಸಹ ಎವಾಪರೇಷನ್ ಅಂತೀವಿ. ಇದ್ರದ್ದು ಕಂಬೈನ್ಡ್ ಎಫೆಕ್ಟ್ ಇದೆಯಲ್ಲ, ಅದನ್ನು ಎವಾಪರೇಷನ್ ಮತ್ತು ಟ್ರಾನ್ಸ್ಪಿರೇಷನ್ ಎರಡೂ ಕಂಬೈನ್ಡ್ ಎಫೆಕ್ಟ್ ಆಗುತ್ತಲ್ಲ, ಅದನ್ನು ಎವಾಪೋಟ್ರಾನ್ಸ್ಪಿರೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಈ ಎವಾಪೋಟ್ರಾನ್ಸ್ಪಿರೇಷನ್ನ ಯಾವ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಯೂಸ್ ಮಾಡಿ ಮೆಷರ್ ಮಾಡ್ತಾರೆ? ಲಿಸಿಮೀಟರ್ ಅಂತ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಇದೆ. ಆ ಲಿಸಿಮೀಟರ್ ಅನ್ನೋ ಇನ್ಸ್ಟ್ರೂಮೆಂಟಿಂದ ಎವಾಪೋಟ್ರಾನ್ಸ್ಪಿರೇಷನ್ನ ನಾವು ಮೆಷರ್ ಮಾಡ್ತೀವಿ. ಇಂಟರ್ಸೆಪ್ಷನ್ ಅಂತ ಇನ್ನೊಂದು ಲಾಸು. ವಾಟ್ ಈಸ್ ಇಂಟರ್ಸೆಪ್ಷನ್? This is the water which is held in the leaves of the plants on the surface of the buildings, right? Which wets the surface of the buildings. This is called interception. Next is depression storage. This is the water which is stored in the depressions on the surface of earth. Whenever the rain occurs, the depressions, first the rainwater fills the depression, and remaining rainwater only it will flow over the land. This part of the rainwater which gets stored in the form of depression, we call it as depression storage. Example for this depression storages are lake, swamp, right, and also ponds, reservoirs, etc. You can see this is about the pond storage, this is reservoir storage. The water gets stored here, and remaining water only it will be flowing over the land, and some part of the water also will gets discharged into the soil surface. Okay, it's infiltrated into the soil surface, and this part of the water which is stored in the form of depression, we call it as depression storage. Next is the infiltration. What is this infiltration? It is a process by which the water particle enters into the earth's surface, moves into the earth's surface, right? This we call it as infiltration. This infiltration depends on various factors. Some of the factors where the infiltration depends on are Say fractured zones, soil surface, the geology is very important. If there is a fractured surface, then there is a rate of infiltration will be more because water infiltrates through these cracks. Right? This we call it as infiltration. Now coming to today's session. What is today's session? We will be discussing on runoff. We will be discussing on runoff. And what are the formulas used for determining this runoff? ಈ ರನ್ಆಫ್ನ ಯಾವ ರೀತಿ ನಾವು ಕಂಡುಹಿಡಿತೀವಿ? ರನ್ಆಫ್ ಅಂದ್ರೇನು? ರನ್ಆಫ್ ಯಾವ್ಯಾವ ಫ್ಯಾಕ್ಟರ್ಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ? ಈ ಮೂರನ್ನ ಈ ಕ್ಲಾಸಲ್ಲಿ ತಿಳ್ಕೊಳ್ಳೋಣ. What is meant by runoff? Runoff is defined as that portion of precipitation which makes it the way towards rivers or oceans. It is that part of precipitation which flows over the land, and which joins rivers or streams. This we call it as runoff. Runoff is that part of rainfall. We can also call this runoff as runoff is that part of precipitation which flows over the land after meeting all the losses. Right? So then what is a runoff? Total rainfall minus total rainfall loss. There are losses will be there. I told you about these losses now. Various types of losses. Interception loss, infiltration loss, right? Then there is a chances of depression storage, transpiration, evapotranspiration, evaporation. These are the losses. Total rainfall minus these losses, that gives you runoff. And runoff is also equal to surface runoff plus groundwater flow. Base flow, we call it as base flow. Runoff need not be only surface, it may also be groundwater. There is a chances of water infiltrating inside and flowing below the ground also. The combined effect of surface runoff and groundwater flow, we call it as runoff. Understood? So, runoff is that part of precipitation which flows over the land after meeting all the losses. The runoff consists of three portions, as I mentioned: surface runoff, base flow, and direct precipitation over stream. Subsurface storm flow or subsurface runoff. What is this subsurface runoff? As I mentioned earlier, the water which gets infiltrated into the soil, you can see here the water which gets infiltrated into the soil, this water flows below the ground and reaches the sea. Okay, the water which flows below the ground and reaches the ocean or sea, that we call it as subsurface flow. The flow need not be on the surface itself. There is a chances of water getting infiltrated and flowing below the ground. That part of runoff which flows below the ground, we call it as subsurface flow. Then groundwater flow or base flow. There is a water after getting infiltrated reaches the groundwater table. You can see here, this water which is infiltrated moves down and reaches the groundwater table, and the groundwater also will be flowing. Groundwater will not be constant. There is a chances of even flow of groundwater. That we call it as groundwater flow. Now coming to estimation of runoff. ಇಷ್ಟೊತ್ತು ನೀವೇನು ಕಲ್ತ್ರ? ರನ್ಆಫ್ ಅಂದರೆ ಏನು ಅಂತ ತಿಳ್ಕೊಂಡ್ರ? ಏನು ರನ್ಆಫ್ ಅಂದರೆ ಈ ಎಲ್ಲ ಲಾಸಸ್ ಏನು ಅಷ್ಟು ಮಳೆ ಬೀಳುತ್ತೆ ಅದರಲ್ಲಿ ಲಾಸಸ್ನ ತೆಗೆದ್ರೆ ಮಿಕ್ಕಿದ್ದು ಏನು ಭೂಮಿ ಮೇಲೆ ಹರಿದೋಗುತ್ತೆ, ಗ್ರೌಂಡ್ ಒಳಗಡೆ ಹರಿದೋಗುತ್ತೆ. ಗ್ರೌಂಡು ಮತ್ತು ಗ್ರೌಂಡ್ ವಾಟರ್ ಮತ್ತು ಭೂಮಿ ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಸಬ್ಸರ್ಫೇಸ್ ಅಂತ ಇರುತ್ತೆ, ಈ ರೀತಿ ಹರಿಯುತ್ತಲ್ಲ, ಇದನ್ನು ರನ್ಆಫ್ ಅನ್ನೋದು. ಯಾಗಪ್ಪ ಈ ರನ್ಆಫ್ನ ಕಂಡುಹಿಡಿಯೋದು? ಯಾವ ಮೂಲಕ ನಾವು ರನ್ಆಫ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು? ಈ ರನ್ಆಫ್ನ ಕಂಡುಹಿಡಿಬೇಕಾದ್ರೆ ಎರಡು ಮೆಥಡ್ ಇದೆ. ಒಂದು ರನ್ ಆಫ್ ಕೋಎಫಿಷಿಯಂಟ್ ಮೆಥಡ್ ಅಂತ, ಇನ್ನೊಂದು ಎಂಪೆರಿಕಲ್ ಫಾರ್ಮುಲಾ ಮೆಥಡ್ ಅಂತ. ಎರಡು ಮೆಥಡ್ ಇದೆ. ಓಕೆ, ಇದು ನೀಟಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ. ಸೊ ಏನಿದು, ಒಂದು ರ್ಯಾಷನಲ್ ಮೆಥಡ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಇದನ್ನು ರನ್ ಆಫ್ ಕೋಎಫಿಷಿಯಂಟ್ ಮೆಥಡ್ಸ್ ಅಂತಲೂ ಕರಿತೀವಿ. ಇದನ್ನು ಈ ರನ್ ಆಫ್ನ ಕಂಡುಹಿಡಿಯಬೇಕಾದ್ರೆ ಕೆಲವು ಕೋಎಫಿಷಿಯಂಟ್ಸ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ದಟ್ಸ್ ವೈ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ರನ್ ಆಫ್ ಕೋಎಫಿಷಿಯಂಟ್ ಮೆಥಡ್. The value of runoff coefficient, see the value of C, we call it as a runoff coefficient. This is the formula. Runoff is equal to cap, CAP. You can remember like this. Runoff is equal to cap, CAP. What is the C? C is called runoff coefficient. A is called area of the catchment. And P is equal to rainfall in precipitation. Whatever the rainfall which occurs, that rainfall in precipitation, which we call it as precipitation, which is called rainfall, you should take it in centimeter. Area of the catchment, you should take it in hectares. Area should be taken in hectares and rainfall in centimeter. And C is runoff coefficient. Now, how do you find out this runoff? How do you obtain this runoff coefficient? This is a table, standard table has been given. From this standard table, the C values will be taking based on the terrain condition, based on land use data, and also based on type of vegetation, that is called land use, right? Based on the land use and soil, type of soil, we are going to classify into different types, and for this classification of different types, we will be taking the value of C. The C value will be taken. The value of runoff coefficient C varies depending upon the various factors. These are the factors. If the surface is rocky and impermeable, the value of C should be taken as 0.8 to 1. And if it is slightly permeable, 0.6 to 0.8. If it is cultivated or covered with vegetation, the value of C should be taken as 0.4 to 0.6. If it is cultivated, absorbent soil, ಅಂದರೆ ವ್ಯವಸಾಯ ಮಾಡುವಂಥ ಜಾಗ, ಭೂಮಿ ಒಳಗಡೆ ನೀರು ಹೀರ್ಕೊಳ್ಳುವಂಥ ಜಾಗ. ಓಕೆ, ಈ ಮಣ್ಣು ಯಾವ ರೀತಿ ಇರುತ್ತೆ ಅಂದರೆ ನೀರನ್ನ ಹೀರ್ಕೊಳ್ಳುವಂಥ ಮಣ್ಣಿರುತ್ತೆ. ಅಲ್ಲಿ ನಾವು ತಗೋಬೇಕಾಗಿರೋ C ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು? 0.3 to 0.4. ಸ್ಯಾಂಡಿ ಸಾಯಿಲ್ ಅಂತ ಇರುತ್ತೆ, ಮರಳು ಭೂಮಿ, ಮರಳು ಜಾಸ್ತಿ ಇರುತ್ತೆ ಸರ್. ಈ ಮಣ್ಣಿನಲ್ಲಿ ಮರಳಿನಂಶ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಈ ಮರಳಿನಂಶ ಜಾಸ್ತಿ ಇದ್ದಾಗ ಈ ಮಣ್ಣಿನಲ್ಲಿ 0.2 to 0.3 ತಗೋಬೇಕಾಗುತ್ತೆ. ನೆಕ್ಸ್ಟು ಫಾರೆಸ್ಟ್, ಹೆವಿ ಫಾರೆಸ್ಟ್. ಓಕೆ, ಸೊ ಕಾಡು ಪ್ರದೇಶ, ಇಲ್ಲಿ 0.1 to 0.2. ನಿಮ್ಗೆ ಇದರಿಂದ ಏನು ಗೊತ್ತಾಯಿತು? ಅಂದರೆ ನಮಗೆ ಈ ರಾಕಿ ಅಂತ ಇರುತ್ತಲ್ಲ, ಈ ಕಲ್ಲು ಬಂಡೆ ಪ್ರದೇಶ ಇರುತ್ತೆ, ಅಲ್ಲಿ ಮಳೆ ಬಿದ್ದಿದ್ದ ನೀರು ಅದು ಭೂಮಿ ಒಳಗಡೆ ಸೇರೋದಿಲ್ಲ. ಅದು ಬಿದ್ದಿದ್ದಂಥ ನೀರು ಇನ್ಫಿಲ್ಟ್ರೇಷನ್ ಲಾಸಸ್ಸು ಕಡಿಮೆ ಇರುತ್ತೆ. ಆದ್ದರಿಂದ ಬಿದ್ದಿದ್ದ ನೀರೆಲ್ಲ ಏನಾಗುತ್ತೆ, ಫ್ಲೋ ಆಗುತ್ತೆ ಜಾಸ್ತಿ. ಅದಕ್ಕೆ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸಿನ ಜಾಸ್ತಿ ತೊಗೊಂಡಿರ್ತೀವಿ ನಾವು. ಆದರೆ ಹೆವಿ ಫಾರೆಸ್ಟ್ ಪ್ಲೇಸಲ್ಲಿ ಇಲ್ಲಿ ಗಿಡ ಮರಗಳು ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಭೂಮಿಯಲ್ಲಿ ಬಿದ್ದಿದ್ದಂಥ ನೀರು ಈ ಭೂಮಿ ಒಳಗಡೆ ಹಿಂಗುತ್ತೆ, ಇನ್ಫಿಲ್ಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಅದೇ ಥರ ಈ ಮಣ್ಣು, ಯಾವ ಮಣ್ಣು? ಈ ಸ್ಯಾಂಡಿ ಸಾಯಿಲ್ ಅಂತ ಹೇಳ್ತೀವಲ್ವಾ, ಮರಳು ಮಿಶ್ರಿತ ಮಣ್ಣು ಅಂತ ಹೇಳ್ತೀವಿ. ಇದಿದ್ದರೂ ಸಹ 0.2 to 0.3 ತೊಗೊತೀವಿ, ಕಡಿಮೆ ಆಗುತ್ತೆ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸಿ. ಈ ಸಿ ವ್ಯಾಲ್ಯೂನ ಏನು ನಾವು ಅಲ್ಲಿ ತೊಗೊತೀವಿ ಸಿನ, ಅದನ್ನ ಇಲ್ಲಿ ಹಾಕಬೇಕು. ಆ ಕ್ಯಾಚ್ಮೆಂಟ್ ಏರಿಯಾ ಇರುತ್ತಲ್ಲ, ಅದನ್ನು ಹೆಕ್ಟೇರ್ಸಲ್ಲಿ ತೊಗೋಬೇಕು. ಪಿ ಅಂದರೆ ಮಳೆ, ಎಷ್ಟು ಮಳೆ ಬಿದ್ದಿದೆ ಅಲ್ಲಿ. ನೆಕ್ಸ್ಟು ರನ್ ಆಫ್ ಕೋಎಫಿಷಿಯಂಟ್ ಮೆಥಡ್ ಅಂತ ಇನ್ನೊಂದು ಮೆಥಡ್ ಇದೆ, ಮೆಥಡ್ 2. ಸೊ Q is equal to KIA divided by 36. This is another formula. In this formula, Q is equal to runoff in meter cube per second, and K is called runoff coefficient. This ಅಲ್ಲಿ C ಇತ್ತಲ್ಲ, ಹಾಗೆ ಇಲ್ಲಿ K ತೊಗೊತೀವಿ. I is intensity of rainfall. ಅಲ್ಲಿ ಬರೀ ರೈನ್ಫಾಲ್ ತೊಗೊಂಡ್ವಿ, ಆದರೆ ಇಲ್ಲಿ ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ರೈನ್ಫಾಲ್ ತೊಗೊತೀವಿ. ಏನಿದು ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ರೈನ್ಫಾಲ್ ಅಂದರೆ 1 ಗಂಟೆ ಅಥವಾ 1 ನಿಮಿಷಕ್ಕೆ ಎಷ್ಟು ಡೆಪ್ತ್ ಮಳೆ ಬಿದ್ದಿದೆ. ಯೂಶಲಿ ಇಂಟೆನ್ಸಿಟಿನ ಅವರಲ್ಲೇ ನಾವು ಹೇಳೋದು. 1 ಗಂಟೆ ಸತತ ಮಳೆ ಆದರೆ, ಆ 1 ಗಂಟೆ ಸತತ ಮಳೆ ಆದಾಗ ಎಷ್ಟು ಡೆಪ್ತ್ ನೀರು ಶೇಖರಣೆ ಆಗುತ್ತೋ ಭೂಮಿ ಮೇಲೆ, ಅದನ್ನು ನಾವು ಇಂಟೆನ್ಸಿಟಿ ಅಂತ ಹೇಳ್ತೀವಿ. Intensity is taken in centimeter per hour, that is I. Then A is area of the catchment, that A is taken as in hectares. A is taken in hectares. And the value of K is obtained using the following table. For urban area 0.4 to 0.8, for cultivated area 0.2 to 0.7, pasture 0.1 to 0.4, and forest area 0.1 to 0.4. These are the values of K which are to be taken for different conditions. Next, we will go for the empirical formula. There are many empirical formulas which are used for finding runoff. One is called AN Kosla's formula. According to this AN Kosla's formula, runoff R is equal to P minus T divided by 3.74. What is this R? R is the runoff in centimeter. P is the rainfall in centimeter. R is runoff. P is rainfall in centimeter. Then what is T? T is the mean temperature in degree Celsius. Degree Celsius ಅಲ್ಲಿ T ನ temperature ತಗೊಂತೀವಿ of the entire catchment area. So Kosla is a scientist who gave this formula for finding runoff. According to this Kosla, R is equal to P minus T divided by 3.74. Using this formula, we can find out this runoff. Next is Lez's formula. According to this Lez's formula, R is equal to P divided by 1 plus 304.8 F divided by P into S, where R is called runoff, P is rainfall in centimeter, F is monsoon duration factor, and this monsoon duration factor varies from 0.5 to 1.5. The F value varies from 0.5 to 1.5, and S is equal to catchment factor. Understood? So S is equal to catchment factor, which varies from 0.25 to 1.7. It once again, the catchment factor depends on the catchment characteristics. Next is CC English formula. Here CC English has given two formulas. One is for GOT areas, that is mountainous terrains, and other one is plain area, which is called as non-mountainous terrains. According to this English formula, the runoff is given by 0.85 P minus 30.5, where P is called as rainfall in centimeter or is runoff in centimeter. And this runoff R for non-GOT areas, that is P minus 17.8 divided by 254 into P. Here also P is called rainfall or is runoff. These are the various formulas which are used for finding the runoff. Okay, so I will stop here. We have discussed in today's class what is runoff and what are the formulas which are used for finding runoff. Thank you.